Hello, everybody. Welcome to another exciting episode of JavaScript Jabber. I am Steve Edwards, the host with the face for radio and the voice for being a mime, but I'm still your host. Today with me, I have one other person, fellow panelist Dan Shapir, ringing in from Tel Aviv, Israel. How you doing, Dan?
I'm doing great. The weather is wonderful, a bit on the warm side, but can't complain.
Right, but the politicians are still awful, right? If I
Oh
remember that
yeah,
correctly.
they're only getting worse. I don't know. Sometimes it's difficult to tell if all I can say is that their incompetence is getting in the way of their skullduggery, or however you
Skullduggery?
pronounce it. Skullduggery. That's it.
Skullduggery, yes.
Yeah, that's the way you
Yes.
pronounce it. So yeah, that's the best thing I can say about them.
Yes, the same is true here, so you're not alone in that. So Chuck is running around Disneyland as we speak, and for some reason he made that a higher priority. I don't get it, but it is what it is.
Yeah, it is what it
Uh,
is.
and AJ's busy, so it's just Dan and I doing another intercontinental podcast episode. So
Mm-hmm.
today, Dan is going to be doing most of the talking because we are talking about things coming down the pike from TC39. This is stuff that's right up his alley. So we've got 1, 2, 3, 4, 5, 6 things, maybe more, depending on how we address them,
Yeah.
coming down from TC39. So with that, Dan, take it away.
Yeah, I like to keep abreast of what's going on with our favorite programming language, especially given that AJ is not here. So it is, we can say that it's our favorite. Things are keep getting added to the language. The rate seems to be slowing down, but there are some really interesting additions happening. Now we had episodes about it in the past. Most recently, we had an episode with who was it?
Thomas.
Thomas Randolph, episode 532, where we spoke about some, I don't know, 10, 20 proposals, something like that. And it was such a lengthy discussion, it actually became a two-parter. But interestingly, the things that I recently noticed that are, really being added to the language kind of as we speak are things that we didn't even discuss during that conversation. So, it's funny how, we kind of missed it. Either the committee did some end run or something, or we just failed to notice it. But in any event, I think they're pretty interesting, and some of them at least are also pretty useful. So I thought that it was definitely worth a discussion. But before we actually dive into the details of those proposals, I want to briefly recap the process that TC39 uses to decide to go through adding features into the language, because they don't just do it willy-nilly. They have this whole process with multiple steps and stages, and and that's what I would like to run through. So that's the first thing. So it turns out that TC39, in the process of adding stuff into the JavaScript programming language, actually has 5 steps, starting with step 0, because everything's supposed to be 0 based in JavaScript. Yeah. So stage 0 is basically when somebody approaches the committee and says more or less, I have a cool idea and here it is. So it's really a mechanism for allowing essentially almost anyone to propose additions or changes to the language. That's more or less it. But to be an actual candidate into the language, you have to move to stage 1, where you need to make a concrete case for the addition of that feature, describe its structure, identify potential challenges with it, and probably the most importantly, you need to identify some champion who will advance this addition, lead the task, as it were. So that's stage 1. Stage 2 is a stage in which the feature gets precisely described in terms of syntax and semantics. using a formal specification language, and the committee, things move to stage 2 when the committee expects that there's a good chance that they'll eventually actually make it into the language. It might take a while, it might even take a long while, but there's a good chance that it will be added to the ECMAScript language specification. And stage 3 indicates that effectively it kind of will be added. The discussions have reached a stage where there's no more to discuss about it. It looks good. They want to add it. They are looking for potentially further refinement, but one that stems from actually trying out that feature in the field. So that's stage 3, when you will start seeing those features implemented in transpilers or maybe even in JavaScript engines behind, let's say, a feature flag or something like that. And the final stage is stage 4, which basically says that the feature is ready and it's just waiting for the next official version of the spec. So because there's a version released every year, you kind of need to wait for that document to come out, but it's actually already officially part of the language. So those are the 5 stages of adding a feature into the ECMAScript language specification so that it does get added into JavaScript.
So let me ask you this question before we get into details. And this is one of the things I've always wondered because I'm not, a real low-level programmer. So ECMAScript, or the committee decides, okay, let's implement this, right? So now you've got the different browser engines. You got the different manufacturers, Chrome, Firefox, Safari, and their underlying engines. So are the implementation details of how it's implemented in each browser up to the browser manufacturers? I mean, it's basically, okay, here's what needs to happen, make it happen. We don't care what happens as long as the end result is the same across the board. Is that how that works?
Yes, but in that regard, it's no different from, let's say, the DOM specification that comes from the W3C. The engines are separate and distinct. They don't share code between them.
Right.
So yeah, the implementation might be done in a completely different programming language, for example. Certainly a different implementation, a different open source project. Yeah. But they do need to adhere to the standard, and all the engine builders or creators are actually have members in the TC39 committee.
Mm-hmm.
So nothing really can get added into the language unless the engine makers all agree that it can and should be added into the language. So if they don't know how to implement it or think that there's a problem in implementing it, it won't get added.
Anyway, that was all my question. Just a little clarification on the underlying work once the committee says do it.
Yeah. Some things are tricky. There's the kind of quote unquote infamous case of the tail recursion or tail optimization for recursion. When you can call a recursive function kind of infinitely without exploding the stack, which turned out to be actually it kind of got added into the language, and then it turned out that it was actually tricky for some of the browser for the engine builders to actually properly incorporate it into their into the engines, and turns out that as a result it mostly hasn't been. So these things can theoretically happen, but they really strive to avoid them. So I'm actually going to go through the proposals, starting with several proposals in stage 3. And then if we have time, work our way into a few proposals in stage 2, and then even maybe one that it's still in stage 1. Because obviously the more interesting ones are the ones that are, effectively going to be a part of the language, not ones that are kind of stuck in purgatory. So yeah. And the funny thing is, what kind of drove me to propose this topic is that I saw 2 unrelated tweets about language features that are in stage 3 and that are actually being implemented. So that and looking at what they do and say, hey, I'm not familiar with these. So I actually started reading about them and try to figure out why they might be helpful, what I think about them, and that's kind of what I want to talk about today. So the first proposal that I would like to mention, which, as I said, is in stage 3, is called the using keyword for automatic resource disposal. And it has to do with objects that have a lifetime or a time span associated with them. Good example might be an object that encapsulates a database handle that you want to close when you no longer need that database connection, or maybe something that encapsulates WebSocket that, again, you would like to close once you don't need that WebSocket anymore, or maybe a file handle. There are plenty of such examples. Now, you might think, why do we need to explicitly control object lifetime? I mean, don't we have the garbage collection for that? And doesn't the garbage collector automatically dispose of such resources? And the answer is that it does, or it can. But the problem is with the garbage collector that you don't really have any control about when it runs. So it might be in a few seconds, or theoretically could be in a few minutes, or maybe even never. And as a result, it means that such resources might hang around a lot longer than you might want or might expect. Now, when resources are plentiful, like memory, then that's not a problem. But when resources are scarce, like database handles or like file handles or network handles, then you want to dispose of them as soon as you don't need them, so that the system can reuse these resources for other tests. Otherwise, it might try to obtain a database handle and fail. So you really want to have kind of this guarantee, as it were, that as soon as you don't need that resource anymore, the system becomes aware of it and can reclaim it. Now, what usually happened in these kind of cases is that you would use something like try finally. So you put the part where you create the resource or claim the resource in a try block, and then you would have a finally block associated with it, where you would call some sort of a dispose or release or close method on that object. Now, what that guarantees is that which way you exit that try block, be it because of a return a statement or an exception being thrown or whatever, the language guarantees that the finally block will execute, and then you get that chance to explicitly release that object. But that can get kind of tricky, because you're really putting the onus of properly releasing resources on the code, on the user, on the developer that's actually using that resource. Like if you're building a library that encapsulates database handles, what you really want is for the library itself to kind of implement the mechanism to guarantee proper resource lifetime, and not to be dependent on the developer that's using the library, especially because it can get tricky to properly nest and order finally blocks. Have you actually used finally blocks in your code for that kind of purpose?
This is the first I've ever heard of a finally block, to be honest. Tells you how much of an in the weeds developer I am. I've used try catch. I've seen it and maybe used it here and there, but I have never used a finally block before.
To be honest, unless again you're dealing with resources like database handles from within your JavaScript code, then you probably don't need to.
Right.
So I'm from what I know, you primarily use other programming languages on the back end for stuff like that.
Yeah, I mean that
Uh,
makes sense. We deal with the same thing in PHP. On the server side, where you got database connections, you got to open them and close them, and how all that gets handled. In my case, it's usually been abstracted away by Laravel or Drupal or something like that. So, but when I was first writing PHP before those existed, then yeah, I can remember dealing with database connections, but they were usually server side, not JavaScript side, client side.
Well, yeah, it has to do with the fact that the JavaScript is much more used on the server side these days. I
Right.
mean, on the client side, lifetime usually is not a problem in any event so much because everything gets released or closed anyway
Mm-hmm.
when you close the tab or navigate away or whatever. So really, the main issues with the long-lived objects and long-lived sessions and scarcity of resources usually has to do when you're running JavaScript on the back end,
Mm-hmm.
which is much more likely than it ever has been now that we've got all those JavaScript frameworks like claiming the back end,
With
as
Node
it
being
were.
the primary one. Yeah.
Yeah, so we've got React Server components and whatnot that are kind of trying to position themselves as the replacement to PHP in a lot of ways. So yeah, we're likely to be seeing much more code run JavaScript code or TypeScript code running in the back end and having to deal with these sorts of issues. Now, the using keyword, which was introduced for this purpose, is actually derived from or influenced by constructs that exist in other programming languages. Like, for example, I know that C# has this mechanism and also uses the same keyword for it. So they're definitely being influenced by other programming languages in this context. Now, the way that this feature works sounds a bit complicated, and hopefully I can explain it verbally, without code demos. But it's actually fairly straightforward, I think. Um, so the idea is that if you've got an object that you want to have it do its own cleanup, so you have like an object instance that encapsulates some functionality. Let's say it has the database handle in some internal field property, and you want it to close that handle automatically when it's no longer needed. What you do is you specify a method on it, and that method needs to have a special name, and that special name is symbol.dispose. Uh, it we
Right.
spoke about symbols in the past. Symbols are
Mm-hmm.
like these unique identifier values that you can use instead of strings for property names, and they are kind of guaranteed to be unique, so you don't get conflicts with userland code, and there are a bunch of such global symbols that are defined in order to specify um, language level properties or methods that people can put on their object. For example, iterators have also used this kind of thing to specify the how for getting the actual iterator out of an object. But anyway, so what you would do is you would do an open square brackets symbol dot dispose close square brackets, that would, and then colon and the method definition, and in that way you can, if you put an expression inside of a bracket in this way, it can actually calculate the property name. So in this case, again, the property name would be symbol dot dispose, and then when you want to use it, what you do is you basically use the using keyword. So
Mm-hmm.
you write using x equals the constructor of like the constructor of the object, the actual object. Sorry. So you assign the object into a variable, but you declare the variable instead of using const or let, you use the new using keyword. And what this guarantees is that when that variable goes out of scope, for example, basically at the end of the block or at the end of a function, then it guarantees to invoke that dispose method. So you got a mechanism in which you can guarantee that the cleanup code will execute when the variable goes out of scope, when it effectively dies. I'm hoping that I described it clearly. We will put a link to a short blog post about it that Matt Pocock wrote. And once you see it in the code, it's just like 5 lines of code, so it's really easy. So, like I said, you just add a property with the specific name to your object, and when you assign that object into a variable, you declare the variable with the using keyword instead of const or let. That's all you really need to do in order to get this functionality. And because you don't need to mess about with all the try and finally and stuff like that, again, when the variable dies, then that cleanup method will be invoked. It's guaranteed. So that's what that way we can get guaranteed cleanup. Now, interestingly, this is going to be part of TypeScript 5.2. It turns out that TypeScript, they don't, or let's put it differently. Let's say it in a positive rather than a negative tense. They only add things into TypeScript these days when they know that they're going to be part of JavaScript. And since things that are in stage 3 are going to be part of JavaScript, it might take a while, but they will be, they feel okay about adding them. So that's why they're okay with adding this feature into TypeScript 5.2, even though it's not yet supported by your browser. So I'm assuming that TypeScript will transpile this code for now into some sort of try finally thing. But eventually, when JavaScript does support it, then they could just emit the JavaScript code that will look like the TypeScript code just without the types. So far, so good?
So far, so good. It's actually making sense.
They're also doing like the ability to specify instead of dispose. They're also going to have an async dispose, which basically just awaits on the dispose to finish before it proceeds going out of the block. So, for example, if I don't know if closing the database is an asynchronous operation, but you don't want to proceed with execution before it finishes because maybe you're worried that then you'll try to get a new handle and fail, and you want to guarantee that the handle will be available, then you use async dispose instead of dispose, and the method is asynchronous, and it just works that way. So that's the first interesting feature that I wanted to bring up. And again, it's interesting that when we spoke about the TC39 features that we liked, this one never even came up. I don't know how we missed it. Again, maybe it was just flew through the process and we just didn't notice it back then. So that's the first one. The next one that I want to talk about is actually one that's kind of near and dear to my heart in a lot of ways, and that's iterator helpers. If you may recall, Steve, I had an entire 2 episodes on iterators and generators in JavaScript and why I think they're great. But it's also undoubtedly true that they've kind of failed to a great extent because hardly anyone ever uses them explicitly. Generators make it really easy to create, your own custom iterators, but very few people that I know of actually use it or even really understand how it works.
What's a use case for creating your own custom iterator?
Well, if you're creating some sort of collection or sequence, um, it's just a really nice way of encapsulating iteration. A lot of other programming languages, by the way, have their own iterator libraries and implementations. Java has it, C++ has it, a lot of programming languages have it. Um, and for example, Dino actually uses it. So if you want to process streams of data, let's say data coming over a socket or a WebSocket or something like that, you can actually encapsulate it as an iterator or a synchronous iterator in Dino, which makes it really nice because you can write your processing code as if it were a regular for each loop or for of actually loop. So it's really nice in that regard. Um,
So in other
and
words, you can handle all, you can sort of, what's the term I'm looking for? Handle all the custom stuff behind the scene, but from a top level code, it looks like you're just iterating over something.
exactly, you just use, let's say, a for of or for a wait of. It looks like a regular loop over an array or something, but underneath the scenes, it's actually potentially doing something much more sophisticated, like reading blocks off of the network or file system or whatever. In that regard, it's really cool. It's really nice. You can theoretically create your own data structures if you want. For example, map and set in JavaScript actually support iterators. So instead of copying their content into arrays, you can iterate on top of them directly. Now, but like I said, unfortunately, most people just don't do it. And if they use iterators, it's really behind the scenes for things like the spread operator, and they might not even be aware that it actually even uses iterators in order to implement it. They just use it and it works. Um, Now, one of the reasons I think that people kind of avoided iterators is that when you wanted to do anything more sophisticated with such sequences, like, I don't know, map them over them or filter them or search inside of them or whatever, at the end of the day, you would end up just effectively just copying them into arrays and then doing those operations on arrays. And in that case, well, you might as well just work with arrays to begin with. Um, and the reason for that is that all the iteration methods that we're familiar with for arrays, like map, like filter, like find, etc., just didn't exist or don't exist for iterators. Um, and this is unlike other programming languages which have iterators, which do provide such helper functions or iteration functions that you can use on top of iterators. So again, if you had like a map of stuff and you wanted to, I don't know, filter on top of it or whatever, you would end up spreading it into an array and then filtering on the array, something like that. And obviously, again, then in that case, why not just use an array from the get-go? So apparently, in order to finally deal with it, TC39 has moved to stage 3, the iterator helpers proposal, which what it does, it exactly provides all this missing functionality for iterators. So they specified a prototype for iterators, and on this prototype, they put all the functions that you expect, like find, actually find, not sure about find, but I know that let me check what they put. They put in, they do have find. They have sum, take, for each, to an array, to create arrays, reduce, exactly like the functions that you find on the array prototype. They now exist on the iterator prototypes as well. So you can get an iterator and then just filter it or map over it or do all those things, and it's built in and it's really nice. And we will see if it finally, causes people to start using iterators in their code, or maybe maybe that ship has sailed and we kind of missed the boat, to continue with my nautical metaphors. But yeah, that's the idea. Overall, I'm personally really happy with it, but I do have a bit of criticism. And the criticism I do have is that, like I said, they decided to implement it as methods on the iterator objects, which means that you chain the functions like you do with arrays. So you would, let's say you have an iterator x, you would do an x dot map dot filter dot find dot sum dot whatever. And I guess that's kind of what most people expect, because, like I said, this way it looks and feels like arrays without actually having to copy the values into arrays. But on the downside, I think that in an ideal world, they should have implemented it as functions rather than as methods, so that instead of chaining using the dot operator, we would have piped it from one function to the next. Hopefully, I'm explaining it this kind of well.
Yeah, I get what you're saying. I don't understand why though. What's the benefit of one over the other? I mean, I'm used to chaining stuff all the time, whether it's in PHP or JavaScript. So what's the benefit of piping it through functions instead of chaining?
First of all, it's more functional. And that seems to be kind of the way where the coding world is headed. But and especially when you think about how a lot of the frameworks these days work with expressions and values rather than objects explicitly, like if you think about stuff like JSX and stuff like that. But the main advantages from my perspective are first that it makes the mechanism much more extensible. If you want to extend the mechanism that's dependent on chaining, you have to add functions to the prototype. And as we know, that's a recipe for naming collisions. So somebody will say, hey, you're missing, there's another iteration method that I would love to have, and for some reason you didn't add it into the spec. But I want to use it for my iterators. So I will just add it to the prototype, because that's the only way I can introduce it into the chain. But then the ECMAScript, the TC39, eventually might decide to actually add it, and then they'll create a conflict. And this has happened with the array methods. So if you have it as a standalone function, well, then, there's no chance of collision. It also makes it much easier for stuff like bundlers to drop dead code. So you only really need to bundle the functions that you use, rather than having to kind of put in everything that might exist on the prototype. So there are a couple of benefits here. And so, like I said, being functional and dealing with expressions and not necessarily requiring object instances for that, making it extensible and lighter weight for the bundling. I actually wrote a blog post a long while back about how such a library might be implemented as a collection of pipeable functions. Maybe I'll put a link in the show notes to that. But again, I guess that having it even as chain methods is better than nothing. That's for sure. Because, like I said, for now, currently, iterators are almost dead, and partially for the lack of such a library.
Okay.
At least that's what I'm thinking. Can't prove it. The first version of this iterator helpers will be just for synchronous iterators, which means that it won't, I talked about using iterators for sequences like stuff coming over the network. So it won't be applicable for that. For that, you need to support asynchronous iterators, and that's actually also, there's also a proposal for that, but that's currently only at stage 2. So stage 3 is for synchronous iterators, and stage 2 is for asynchronous iterators. But it really looks similar. Now, what's really interesting is that Google has announced their intention to actually implement this in Chrome. So it's going to come out in Chrome version 1.14, behind a feature flag. So you would need actually to put a flag on the browser's command line if you want to get it. But it does mean that we will be able to start playing with it, which will hopefully push it more quickly from stage 3 to stage 4 and actually getting it released and implemented in all the browsers. So that was the second feature, the language feature that I wanted to talk about. Anything before we move on to the next one?
Nope.
Okay. Have you ever used sets in your code? I'm talking about the JavaScript sets.
I have looked at those, haven't usually used them. Like I said, I'll usually revert back to what I'm familiar with, so haven't played with the methods too much, although looking back, I dare say there might have been times when a set would have worked easier than all the manipulations I went through.
Yeah, so set is this collection that's been added to JavaScript a while back, which basically is just a way for you to indicate if something is part of the set or not. So you add stuff into the set, like let's say strings. You might add, Dan, AJ, Steve, Chuck into a set, and then you would check. So putting in Dan or Steve would basically, you could check that they are in it and it would return true. But if you check about Amy, unfortunately, you will find false because Amy is no longer participating in the podcast. So set is really a simple way to check if things are part of a set or not. And like I said, it can be strings, it can be objects, and it's really easy and simple to use. And it's been around for a long while now. It's supported by all browsers.
So in other words, it's cleaner than doing like if index of something is not equal to -1
exactly
type of structure to see if something exists. And
yeah, it's simpler. It's more intentional because when you use the set, it's really clear when reading the code what your intention is. Whereas if you're using an array and then using includes or index of to check if something is in it or not, it's you kind of need to read the code and figure out the intent. It's
so how does it work with lists of things like with like objects? So often
by
one
reference.
of the things by Google. So in other words, if I have a list of objects and I want to say, okay, I want all the objects that have this key, 3 levels down type of
no,
thing.
it's not.
Does
not
it handle
for that.
stuff like that?
No,
Okay.
no. It's just by reference. It doesn't actually do any sort of comparison. The one more thing I wanted to mention about sets is also that they're much more efficient because a mechanism implemented on top of an array is O of n, where n is the length of the array, because you effectively need to essentially iterate through all the members of the array in order to check if something's in it or not. Whereas with a set, they use some sort of a built-in, I assume it's implementation dependent, but they use some sort of a hash or a tree in order to create a much more efficient implementation. So the lookup is probably, let's say, log n or maybe even constant in many cases, and certainly not O of n. So that's the big advantage of those are the big advantages of using a set. But it always felt that something was kind of missing with sets, because when we're dealing with sets, there's a whole bunch of mathematical operations that seem natural to do. For example, you might want to get an intersection of two sets or the union of two sets. But so far, those methods or mechanisms were not implemented as part of JavaScript, so you would have had to do them yourself, and which is obviously an invitation for implementation bugs. So now they are going to be provided out of the box as methods on the set prototype. So you can just take a set. Let's say I have two sets. I have a set referenced by the variable x, and I have another set referenced by the variable y, and I want to get a set which is the intersection of these two sets. Then I can do x dot intersection, open parentheses, y, close parentheses. And what I will get in as a return value is a new set, which is the intersection of these two sets. Likewise, I can get the union of two sets, or the difference between two sets, and so forth. So it's just a collection of useful methods to have on top of sets, and it's really great that it's being added to the language. And again, probably long overdue. We keep on talking about the fact that JavaScript is kind of missing standard library, and it seems that slowly but surely TC39 is working to rectify this. So partially it's been doing it, let's say, with the iteration helpers or iterator helpers that I mentioned before, and it's also doing it for sets with the set methods. And that's all there is to it. It's pretty straightforward and, obvious feature to add to the language. The next one is much less obvious, but on the other hand, probably more familiar to a lot of JavaScript developers, and that's language support for decorators. That one we might have actually mentioned in previous episodes. I don't remember off the top of my head. But anybody who's ever used Angular, or let's say Nest.js, or has just come to JavaScript from other languages like Java, is probably familiar with the concept of decorators, and the implementation looks essentially the same.
Let's start out. What's a decorator and what's the benefit of it?
So decorator is something that you use with classes. So that's both the upside and the downside of decorators, at least in JavaScript, that they go hand in hand with classes. So if you use classes, there's a good chance you also end up using decorators. And if you don't use classes, then you'll probably never use decorators. The idea is to support something that's technically called aspect-oriented programming, which is a mechanism for managing cross-cutting concerns in a kind of a clear way. I'll try to give an example. Let's say we have a whole bunch of classes in our code which are essentially unrelated to one another. So we don't expect them to inherit from a common base class because they're unrelated. Let's say we have a class for user and we have a class for computer. We could have a class called entity or whatever, but it kind of seems odd. But let's say, despite the fact that they don't have a common ancestor or base class, we want to add common functionality to them. Let's say we want to have logging, let's say, so that every time a method is called on one of these objects, it logs let's say the fact that it's been called and the values of its parameters, and maybe also the return value. So we want to add logging capability. Or another example, we might want to add the ability to serialize objects. We want to control how certain fields in an object are serialized or deserialized into, let's say, JSON. We want to add this functionality of, let's say, serialization and deserialization into these objects. So one way would be to inherit from a common object that implements serialization and deserialization. But like I said, that's kind of odd because, using inheritance for that creates like an association that's not really expected. Also, what would we do about the logging? We can in JavaScript, you don't have multiple inheritance. You can inherit from two distinct base classes. You can only inherit from one. So do we inherit from the serialization base class or from the logging base class? What happens if you want to have both? So that's the problem. And decorators kind of strive to fix that. And the way that you do it is you write the @ symbol followed by the name of the decorator in front of a class name or a method name or a field name. And it decorates, respectively, either the class itself or the method or the field / property. And the decorator name is actually just a function name. So let's say you decorated a class, that function is invoked with a reference to the class and some additional information, and what it returns is a replacement or a modified class that is the original class plus logging or plus serialization.
Now it makes sense.
Kind of tricky to explain.
So basically, you're defining another.
That's the concept.
What do you want to call it? Function, method, piece of code, whatever. That you want to run. Was it run every time the class is instantiated? I mean, do you add a decorator to a class and then you have to specifically call that decorator at some point, or is it something that's always run at a certain point in the class lifecycle?
It's actually run when that class is created, as it were. So yeah, it kind of replaces. So let's say you have a class C, capital C. It actually causes C to reference the decorated class rather than the original class.
Okay, so it's sort of it's basically an override, is what it sounds like.
So, yes, exactly. It's an override. It overrides the class, and it creates that override by calling a function, passing in the original class, and getting back the decorated class. Now, we will put a link. It's kind of difficult to explain APIs without actually showing code, but it's actually fairly straightforward. And like I said, it's totally in line with how this mechanism is implemented in other programming languages that support it, and also with the implementation that exists in JavaScript, in existing JavaScript frameworks and libraries like Angular, like Nest.js, and others. So currently these languages use a transpiler to deal with these decorators, and ideally now they will just be able to generate the JavaScript code as is, and it'll just work.
Got it.
So that's the concept of decorators. The last stage 3 item that I wanted to mention is something called Shadow
Sounds like
Realms,
a game or a movie or something,
which
right?
sounds kind of spooky or ominous. Yeah, exactly. Do you want to come to my Shadow Realm? Yeah, kind of reminiscent of Shadow DOM, if you're familiar with that, if you remember that. So Shadow Realm, the idea is that you want to create a distinct global environment. What do I mean by that? Do you know, like when you create an iframe, let's say you have an iframe in your tab, and it's an iframe to the same domain. So you can actually call functions directly with inside the iframe, or the iframe can call functions that are directly inside the containing tab, because they're both in the same domain, but they actually have their own distinct global objects, and they have their own distinct prototypes for the various built-in object types. If you remember, a lot of people, well, not a lot of people, but people would run into surprising issues with that sort of thing. Like they would try to check if some object is an array by comparing its prototype to window.array with a capital A, and it will come out as false because it was an array that was created inside the iframe. So its prototype was actually different. It was also window.array, but it was a different window, so it was a different window.array instance. So, funny stuff like that.
So sort of like a
So
sandbox.
Shadow Realm is a way to be explicit about this, like get similar behavior, but without needing an iframe for it. So a shadow, when you create, yeah, exactly. It's a sandbox. You run script inside the shadow realm. That script gets its own global and gets its own prototypes on the objects. So, for example, if you want to run potentially some sort of an untrusted script, I don't know, third-party cookies, whatever, you can run them inside of a shadow
Yeah, makes
realm
sense.
instead of inside your global environment, and then you have assurances that they're not polluting your global environment in any unexpected sort of a way. I know that a lot of people have been looking for something like this for a long time. It will be interesting to see, how this feature is used. Anyway, so those are the, what is it, 5 stage 3 additions to JavaScript that I wanted to talk about. Like I said, because they're stage 3, they're all going to effectively make it unless there's like a last minute surprise or something. And we might expect to see them implemented in browsers in a year from now or something like that. Some of them, as we saw, even sooner than that. Do we have time, like a bit of time, to go over the few stage 2 items?
Yeah, we got a couple. We're getting close to an hour, but yeah, we could drop a couple in.
Yeah, so I already mentioned one, which was the async iterator helpers, which were like the iterator helpers, but for asynchronous iterators. So instead of just iterating over collections like a map or a set, with async iterators, you can iterate over sequences like data coming in over the network or a sequence of events or stuff like that. And there's a proposal to add helpers like map, filter, etc. for those types of iterators as well. Makes sense. Why if you need them for one, then you also need them for the other. And I don't see any reason why this wouldn't get added eventually to the language. The other stage 2 proposal is one that's also kind of interesting in that it's how is it that this thing doesn't exist yet, which is iterator.range. Think about it this way: how many times have you wanted to like created, or let's say that you wanted to create an array filled with, let's say, the numbers 0 to 1000, and you had to write like kind of obnoxious code, non-trivial code, in order to do it, quote unquote, cleanly and efficiently. It seems like this kind of thing needs to be built in. If you want to iterate over a sequence of numbers, let's say, and you don't want to use a for for it, you want to do it in kind of this functional sort of a way. So that's what ranges provide you with. And it's something that exists in a lot of programming languages. I think you've got it in Python, you got it in Kotlin, you've got it in a lot of programming languages that support this kind of a construct. So you do like the iterator.range, and you specify the start of the range, let's say 0, and the end of the range, let's say 100. And what you get in return is an iterator that basically goes through all the values from 0 to 100. And you can even specify a skip. Again, anybody who's familiar with Python is like banging their head and saying, "How is it that something like that hasn't existed before?" So yeah, it's pretty obvious. Again, it's kind of difficult for me to explain it without showing code, but we'll give the link, and it's pretty obvious. And the nice thing about it is that it works really nicely with the iteration helper functions that I mentioned before. So you can do a range and then filter on the range and then map on the range and then and then let's say convert it to an array if you want to get the final result as an array of values, whatever. It's really nice. So is it clear? Hopefully I managed to explain it clearly enough.
Yeah, as much as it clear as it can be without actually seeing some code. I mean, we'll deal with iterators, iterating over lists or, arrays generally, arrays of objects, arrays of any number of things all the time. So I'd have to get down
Yeah.
and play with these a little more. But anything that makes it easier to pick something out of an array is always useful out of a set. I know one of the nice things about Laravel is that it has a whole class of tools for that they call it a collection. But there's just a ton of different helper methods in a collection that are designed to help you get things out of your models, which can be very complex. Very easily doing a sum of something or iterating over it and doing all kinds of calculations and stuff that just you can do it in a couple lines of code. Where without that
Yeah, I
particular
think
class, you would have to write a lot
exactly.
more
And I
code.
think that's the key
So
point.
yeah,
We are
iterators are always
writing
useful when
ever
you're dealing with large
larger
lists of things.
and more complex and sophisticated JavaScript applications. So we expect JavaScript, the programming language, to support this with constructs that make writing larger code bases easier. And we've talked about the lack of a standard library in the past. Standard library being a collection of useful functions that you can use. And like I said, it seems that TC39 is trying to step up to the plate in this regard and kind of fill in the blanks, or at least the most glaring, obvious missing pieces. The last one that I want to talk about before we head on over to picks is one that's actually in stage 1, which means that there is absolutely no guarantee that it will make it into the programming language. In fact, it's been stuck in stage 1 for a long time, which kind of makes me fairly pessimistic about it. But I wanted to discuss it nonetheless, because when I saw it for the first time, I was actually opposed to it. And now I'm coming around to the conclusion that I think that it's actually really needed in the language and useful. And I'm actually hoping that they'll find some way of moving it beyond stage 1 and actually adopting it into the programming language. And this feature is called do expressions. It often confuses people when I mention it because they assume I'm talking about do while, which is a pretty esoteric language feature as well, but one that's been part of the language from day one because JavaScript kind of inherited it from C. But apart from reusing the same keyword, the do keyword, it actually has no relation whatsoever to the do while loops. So let's forget about do while loops. Let's not even discuss them. And let's focus on do expressions instead. What do expressions are they are essentially a mechanism for writing complex expressions, or actually a better way to put it would be to use statement keywords inside of expressions. What do I mean by that? In JavaScript, unlike some other programming languages, specifically functional programming languages, makes a very clear distinction between things that are expressions and things that are not expressions. And certain JavaScript keywords are not expressions and cannot be used as part of expressions. For example, the for loop cannot be part of an expression. If you want to have a loop inside of an expression, you need to use some sort of an iteration method like a map or a filter, which returns a value. A for loop does not return a value. Yeah, another example of something which isn't which can't be used inside of an expression is if statements. If we wanted to have conditionals inside expressions, we had to use ternary expressions.
Okay, that's what I was going to say. You can do it just with ternaries.
Yeah, but that's much less readable, especially when it becomes complex. I'm sure you've seen situations where it's question mark, colon, question mark, colon, question mark, colon, and so forth. And
Multi-level ternaries, yeah, they're
yeah,
confusing.
And ifs are more explicit and easier to read, but they can't be used as an expression. So do expressions change that? You do, let's say, let x equals do open curly brackets, and from that point on until the end of the curly brackets, everything in it behaves differently. It behaves as if it's part of an expression. It's kind of like using an iffy, a self-invoked anonymous function, where you want to assign some value into a variable, and it's a sophisticated computation, and it's hard to do as a simple expression, but you don't want to create a global function for it. It's a very localized computation. So you might use an iffy for it. You know what I'm talking about?
Yes, immediately invoking function expression. Isn't that what that
Yeah,
stands
but
for?
there's a lot of boilerplate associated with it when you're doing it. There's a lot of open and close parentheses in order to get it to work, and it's always slightly confusing, especially for newbies.
Yeah, we had to use them a lot with jQuery. If we wanted, I know inside the Drupal world, that was how we implemented things with ifs, where you had your function and then the parentheses afterwards that caused it to be invoked.
Yeah, how would Douglas Crockford always refer to them as gonads hanging on at the end of the function of the iffy.
I can see that.
But yeah, so do expressions actually do away with all these parentheses, but it goes beyond that, because inside the do expressions, semantics actually change. So an if can become a part of an expression. And the value of the if, you don't need to put returns in it, actually, because the last value that you get to, that's the value of the expression. So you might do something like, if something, 0, else 42. And you don't need to put the return. You just write that value in it, and that gets returned, quote unquote, as the value of the do expression. Again, difficult to explain without showing the code. We'll put a link to the actual proposal. So it actually changes the semantic of the language inside. Yeah, but it doesn't use the return value. It's just the last value inside. You just write the value, and that last value, instead of basically doing nothing, gets, quote unquote, returned as the value of the do expression.
Okay.
So you could do if something 1, else if 3, else if 42, else 0, stuff like that. Now, that's the reason that I initially disliked this proposal, because inside the do expression, it changes the semantics of the language. And that's kind of scary. Certainly for newbie programmers, where they suddenly see familiar statements working differently. And that's why when I saw it, I said, okay, cool, but I don't want it. But now, like I said, I do actually want it. And there are a couple of reasons. The first reason is that these days, we're creating in our JavaScript code really sophisticated expressions, much more so than we've ever done. And the reason for that is JSX. Because when you return JSX, that's an expression. And if you want to have conditionals inside of the JSX, which you often do, render this or render that based on some value, then these days you use ternary expressions, and it can get pretty hairy. And if you want to do loops, then you have to use maps and filters. You can't use for. If you do want to use for, you have to kind of explicitly split it into like its own separate function or something, which is kind of annoying. And do expressions solve all that. You can put a do expression inside of your JSX, and all of a sudden inside the expression, you can actually use ifs, which makes the code a lot more readable, I have to say, from examples that I've seen in the proposal itself. So JSX, and JSX is, I know that you come from the Vue world that kind of eschews JSX, poo-poos it, whatever, call it whatever way you want. But effectively, all other frameworks are kind of adopting it. So obviously React, but also Solid and Quick and others. So JSX is kind of a big part of the web development these days. And anything which can make JSX better, I think the programming language needs to align with the way in which developers are using it. And a very large portion of the JavaScript developers, maybe even the majority of them, are using JSX and therefore can really benefit from Do Expressions. Do Expressions actually have two additional benefits, which I'll explain really briefly. One is that they inherit the ability to call await from their containing function. So if their containing function is async, they can await, and the await behaves as you would expect. It actually blocks the computation of that expression, and which is kind of much more challenging to do with an IFI. So that's one big benefit of it. And the other is that you can actually use the return statement inside a do expression, and it will actually return out of the containing function. So that's really cool. You can really short circuit from the middle of an expression, which can be really useful in some cases. So it definitely has benefits, and that's why I've gone from, being against it again for changing the semantics of the language to being for it, because I think it's just really beneficial given the way in which a lot of developers are using JavaScript these days.
Yeah, I mean, I could see some use cases for that, because there are times when, even in Vue, the non-JSX language, where you want to do an expression to bind or to calculate a particular class you want to bind to the style element of an attribute, or attribute of an element, excuse me. Or any number of things that you want to do where you can use an expression, but you're limited, by space. Where being able to do that, I could see, would provide a lot more flexibility for sure.
So, that's it. Those are the proposals that I wanted to talk about today. Hopefully our listeners found it interesting. I know that some people, like AJ, for example, or unfortunately couldn't be here, kind of don't like the fact that JavaScript continues to grow in this way. And I can totally understand why, because JavaScript has become a much more complex and sophisticated programming language than it used to be. Now, obviously, you can choose to avoid certain aspects of it that you dislike, but you can't really maybe prevent your colleagues from using it, which means that you'll end up having to deal with these additions whether you like it or not. So I can understand where AJ is coming from, but I do think that at least some of these additions are making the language better. Definitely the ones that are effectively creating a standard library on top of it, which is, like I said, something that I thought was sorely lacking, and I'm really happy to see this void being filled. So yeah, that kind of concludes my exposition of these new JavaScript features.
We'll have to. I'm sure you'll keep us up to date as they move through the process, right? We'll have to update now and then and see where things stand with these things actually being added and implemented in the Tific browser and their engines. With that, we will move on to picks. Picks are the part of the show where we get to talk about other things other than coding in deep and nerdy JavaScript.
But we're nerds.
We are. I prefer the term geek, but it's all the same.
Yeah, I think we're both.
Exactly. Exactly. So I will start. Found an interesting article today, Hacker News, and it's about nuts. In particular, when in the past, when I've been working on losing some weight and dropping some weight, one of the things you hear about nuts is that they're good. They've got health benefits, but they have a lot of calories, and so you don't want to eat too many. Story I'm reading here today from a triathlete.com article is that they don't have as many calories as you thought. And it really gets rather geeky or nerdy into the science a little bit and how the breakdown of the food in your digestive system works and so on. So it's really good. But the takeaway for me is that I can eat more nuts. Not that I'm already not nuts, as the case may be. So for the dad jokes of the week, let's see. Simple one. This is more along my son's line of thought. So what did a full glass of water say to the empty glass of water?
I don't know.
You look drunk.
Okay.
Right, because it's been drunk. Right.
It reminds me of a joke that I know, where the pessimist sees the glass half empty, the optimist sees the glass half full, and the programmer says we could have used a smaller glass.
Exactly. I recently, we've talked. You read a lot more about recently about like human machine type of interface. I think the Borg from Star Trek is a classic example, and so I've been reading about that more. And so I actually got a clock implanted in my brain, but it didn't take long before I started having second thoughts.
Okay.
Right, second thoughts.
Yeah.
And then finally, this is sort of a religious joke. What do you call a book club that's been stuck on the same book for years? Church. 6 books if you want to get technical, but you get the idea.
Yeah.
All right, Dan, what do you got for us?
Okay, so I spoke at a tech conference recently called JNation in Coimbra in Portugal. And one of the great things about conferences, at least the way in which I attend them, is now that my kids are older and I don't have to worry about what goes on with them, is that we actually turn such speaking opportunities into vacations. So my wife joined me and we toured for about a week and a half through Portugal. Funnily enough, we were actually supposed to do this like 3 years ago, but then COVID happened. So we were kind of also making up for that missed vacation from 3 years ago. And I have to say that Portugal is amazingly beautiful and highly recommended. We went to Lisbon and Sintra and Óbidos and Porto and the Douro Valley and Coimbra, where the conference was held. And it's just a lovely country. One of the great things about it is that Portugal did not really go through a really destructive war since like the Middle Ages. So all the castles and old cities and old buildings are preserved. So you get to see a ton of history there, because in other parts of Europe everything is effectively reconstructed because everything kind of got demolished in the Second World War. And also the nature is beautiful. Like the Douro Valley is amazingly beautiful. So I highly recommend visiting Portugal, and it's my first pick. What's my next pick? My next pick is that I'll actually be speaking at an additional 2 conferences pretty soon. One is in about a week and a half, so it'll probably in the past by the time this episode comes out. And it's called React Next here in Tel Aviv in Israel. It's a pretty big conference. It's over 1,000 attendees, and I know that they're sold out. Our friend Tejas, who I hoped could be an extra panelist, but it seems he's too busy to join us most of the time. is also actually going to be giving the keynote there. I'll be speaking there as well. I'll actually be talking about how different frameworks these days are striving to overcome the performance cost of hydration. It's something that I think I actually spoke about in a past episode on JS Jabber, but I don't remember which one. So probably we'll need to look up afterwards.
Well, I think we talked about it a lot with Quick, with the framework Quick.
Yeah, for sure. Yeah. Which brings me and I'll also be talking at another conference, actually giving the same talk at another conference in Zurich in Switzerland. It's called the Front Conference Zurich, and which actually gives me the opportunity to go visit Austria and Switzerland. So here we go again, and hopefully that will be my pick in a future episode about how great these countries are to visit and tour through. And my final pick for today is that you just mentioned Quick. Mishko Hevery, who created Quick and also previously created Angular, actually visited Israel last week. We've been online friends or virtual friends, and we finally got to meet face to face. And I attended his talk at the meetup, and then we went out for drinks afterwards, and it was really great. He's a great guy. It was a lot of fun talking with him, both in general and also about the great things that they're doing in Quick. So I'll just give Quick a shout out, and I'll say that if you're looking for a framework which provides great performance out of the box, essentially whatever code you write, then Quick is something that you should definitely be looking at. And I think we will have Mishko again on in an upcoming episode, so we'll get a chance to grill him some more about the great and crazy things that they're doing in that framework. And those would be my picks for today.
All righty. So as usual, we are going long here, but this episode is chock full of great information. So you probably need to listen to it twice just to digest the amazing data that is contained in it. With that, we will say goodbye. Thank you to Dan for his details on what we can look for coming down the pike. And we will talk at you next time on JavaScript Jabber.